Alright, good day viewers, and of course, my students out there. I am Engineer Kingsley Efe, popularly known as the Son of Man. And of course, you already know I am the CEO of Son of Man's Tutorial, currently known as what as Brain Judah. And today, I have decided to run a topic which is called some of the properties or characteristics of organic compounds. Now, you know, in my previous video, we saw some of the properties of carbon that enable it to form various or numerous organic compounds. We actually exposed about 3 of them. So today we want to talk about the properties of those organic compounds of carbon. Now, if you look at the board, you'll see that I've already drafted out about 6 important properties of organic compounds of carbon. Now, one of the first properties we are seeing on the board is what is called polarity/solubility. I repeat, polarity/solubility. Now, what is polarity? How do we explain polarity/solubility? We don't really have much to say under this polarity/solubility. Of course, what we needed to know is that a compound is only said to be polar if that compound consists of a very strong electronegative element like chlorine, or if by addition the compound consists of a very strong hydrogen group, which is called OH group. Like we normally refer to OH group as hydroxyl. It's called hydroxyl group. So any compound that consists of this particular group, such compound is referred to as a polar compound. For example, ethanol. You get it? So we have ethanol. Ethanol is what is said to be polar compound because it has OH group attached to itself. You can see this is ethanol so that you're able to see the OH group. This is ethanol, C2H5, then what? Then OH. It's called ethanol. No, this is the chemical formula or the molecular formula of ethanol, which is a member of the alkanol series. Okay, so by the time we get to the homologous series, I'm going to expose you guys to the homologous series and all the members related to the homologous series. So again, talking about polarity, let's fall back to polarity again. I said a compound is said to be polar if that compound consists of a very strong electronegative element like chlorine, or if the compound has a polar group, which is called hydroxyl group. Now, one important question you will see them asking us in WAEC and in JAM is that what is the reason why ethanol is soluble in water? Yes, ethanol is soluble in water because it consists of a polar hydroxyl group which forms bond or hydrogen bond with water molecule. So when you mix ethanol and water, they are both miscible. So you see that ethanol is soluble in water in that case. But let's take, for example, that means a polar compound can only dissolve in a polar solvent, and a non-polar compound can only dissolve in a non-polar solvent. So when we are talking about polar to polar, we are using ethanol and water, for example. But when we talk about non-polar compound and a non-polar solvent, we are talking about a mixture of petrol and of course oil, or probably a mixture of petrol and kerosene. So kerosene and petrol are collectively referred to as non-polar compound and non-polar solvent. So they are miscible. But it is not possible to combine a mixture of petrol and water. Why? Because we already saw that water is a polar solvent, while petrol is a non-polar solvent. So they are immiscible. I think that one clearly explains what we call polarity/solubility. We now go to what we call covalent nature. Of course, if a compound is covalent in nature, such compound they do not conduct electricity. So a covalent compound is a compound that do not conduct electricity. Even though there are other and most times they are normally volatile. They are volatile. They are sometimes volatile liquids or gases in most cases. But we know that one important property assigned to them is that they are normally non-conductor of electricity. Although among all of them, there is a particular organic compound that is normally referred to as a weak electrolyte. And what is that compound called? We call it ethanolic acid, which is CH3COOH. Yes, it can conduct electricity partially because it was meant to be a poor electrolyte. Don't forget that this is meant to be a very weak acid, because we have strong acid which are strong electrolytes, and we have weak acid which are weak electrolytes. So with the exception of this guy, all other compounds you see, all other organic compounds are referred to as they are covalent in nature, and they are non-conductor of electricity. Then what about thermal instability? Yes, this is a very important property assigned to organic compounds of what? Organic compounds of carbon. Now when we say thermal instability, you see most organic compounds they are what? They are thermally unstable. They are thermally unstable because when they are heated, they can decompose into what? Into simpler chains, simpler organic chains. Now, sometimes the process you are seeing here can normally refer to as what? Cracking. What is cracking? Of course, we know that cracking simply means a process whereby a larger chains or hydrocarbon chains are broken down into simpler organic chains. For example, we're talking about, for example, there are two types of cracking. And what are those two types of cracking we have? We have thermal cracking and we have catalytic cracking. As the name implies, thermal cracking. The word thermal means heat. That means once a chain is broken down by heating, it is called thermal cracking. But once a chain is broken down by using what we call a catalyst, we call it what? Catalytic cracking. Now, what is the major thing you see in your exam? WAEC and JAMB, they are now interested in asking us, between the two processes I just said, which of them is more preferable? Yes, I will tell you today now with full confidence that catalytic cracking is what is more preferable. But why is it more preferable? It is more preferable because, number one, the process can be easily controlled. Then number two, the process yields alkanes of desirable chains. Now, those are the two reasons why you saw that catalytic cracking is what is more preferred than thermal cracking. Like, what is thermal cracking? Imagine you are trying to heat up a hydrocarbon chain, and the process is not being controlled. You are just heating at random. Such process can actually lead to the formation of alkanes of earlier chains that we don't really desire in that case. So we now leave what we call thermal instability, and we now go to what we call low melting and boiling point. Imagine the word low melting and boiling point. If I'm actually referring to that, this compound is having a very low melting point or a very low boiling point, it simply means that that the bond has a very important role to play. Of course, when the bond is a very strong bond, that means you have to heat to a very high temperature before that chain can be broken down. Is that so? So, but when we talk about a low melt and the compound is having a very low boiling point, that means that compound is linked by weaker forces or intermolecular forces of attraction. Of course, we are talking about the Van der Waals forces of attraction. Okay, so that's for the low melting and boiling. So many times, when they are heated to a temperature sometimes even below 300 degrees centigrade or Celsius, you see that the chains will be broken down. That's why they say they have low melting and boiling point. We now go to the next property, which is called reactivity. Of course, we are concerned about reactions involving organic compounds. Yes, I can boldly tell us that most of the reactions involving organic compounds, they are usually very, very slow. They are very, very slow. And hence, because they are very, very slow, that is why there is no organic reactions involving organic compounds you see in this part of chemistry that is not enhanced by a catalyst. Why? Because catalysts will only help us to speed up the rate of the reactions. So when the reaction becomes too slow, the only thing that we can use to speed up the rate of the reaction becomes catalyst. So what are we trying to say? Most reactions involving organic compounds are very slow. So to speed up the rate of reactions, we have to use a catalyst must be applied. What about the last one, which is called flammability? Yes, flammability simply means, most times, most organic compounds they are thermally. Sometimes they are highly flammable. When I say they are highly flammable, that means they are volatile, and when they are exposed to air or oxygen, you see that sometimes they burn exothermically. And when they burn exothermically, they will give us a product which is called carbon dioxide and water, and even sometimes steam will be formed. But it is mostly carbon dioxide and steam, or carbon dioxide and water, as per those alkanes, the alkanes and the alkynes. That's when we are going to see this flammability. So the ability when sometimes they burn exothermically. And we all know what we call exothermic reactions. That most exothermic reactions, they involve reactions whereby heat is what is liberated or given off to the surrounding system. And at the end of the reaction, we all know that the surrounding system becomes hot or sometimes becomes warm at the end of the day. So that's what we call flammability. So the process whereby most hydrocarbons or organic compounds, they will react with oxygen to produce carbon dioxide and water as a product. Such reactions normally refer to they are called, what are they referred to as? They are called combustion reaction. So when we say flammability, it is not far from combustion reaction of the organic compounds. So I want to believe it's all that I want to believe from all the information I've actually given is enough for me to understand and at least clearly explain or have a clear picture of some of the properties of organic compounds. Please, 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 let's not fail to subscribe to my YouTube channel. All you need to do is to go to YouTube and search for the name Son of Man Tutorial /Brain Builder. Thank you.